All right, one of the big issues in polynomials is when you cannot factor something and it's a prime quadratic, whatever the case is, and you have to use the quadratic formula. This is one of those things and it's a skill that you just have to know how to do. Off to the right here is the formula. Now, you have to get the equation in standard form and get it set equal to 0. So we see that algebraically done here, where we add the 2 to both sides. We could have factored out a 2, but we're going to look at it just straight up as the coefficients. All right, so everything gets plugged into the quadratic formula. All right, this is based on the assumption that you already are familiar with identifying the coefficient A and B and the constant C. Once you've done that, you plug all of these values in and substitute accordingly. The biggest mistake students make is handling what happens under the radical. You treat that as if it's its own little world, and you work that according to the rules of simplifying expressions, and get what's underneath the radical simplified to a single number. Okay, so we're going to finish this up on the next slide. So here we go. Go ahead and combine what was under the radical. Now we have this goofy number, square root of 112. Well, I cheated a little bit and just tinkered around on a calculator, and I came up with the two factors that 16 times 7 is going to give me 112. Fortunately, 16 is a perfect square number. So that is what we are looking for. Anytime we're dealing with finding the square root of something or trying to simplify a radical, we always want to think of perfect square factors of that number. So now we simplify that to 4 root 7, and we have everything set up over here. Now notice that negative 12, 4, and 8, 4 is a factor of itself, of negative 12 and of 8. So we can simplify that out. Notice 4 will go into itself once, into negative 12 3 times, and we can simplify that expression. And we see what the potential complex roots, or irrational roots, of that particular polynomial are. Negative 3 plus root 7 over 2 and negative 3 minus root 7 over 2.